In part one, we're basically being asked to combine logs. So we need to know our three rules. Log x plus log y is equal to log xy. Log x minus log y, what's that one? It's log x over y. And then log x to the n is n log x. That's essentially a special case. I mean, they're all very strongly linked together. No proof shown here, but we need to know these and then apply them. So we've got a subtraction going on, but I can't do that yet because I've got numbers in front of the original one. So the first thing to do is use the third rule. Bring that power up. And now I can use the second rule. Okay, I'm actually not going to use the first rule. Log to base 3 x squared over x plus 4. No, I needed the bracket here because I was applying a log to base 3 to the whole thing. I don't here because I still am, but it's like I'm saying I've got a division and I'm doing the x plus 4 first, so I don't need the bracket. Okay, and that's that part finished. Now what they've actually done is given us a big hint for part 2. They say hence solve this equation. So actually we don't want to solve it as it is. We've got two logs. We want to combine it, so we've got one log. And then we just need to undo the logs. So just a little reminder, if you had log to base 10 of 100, then what that is saying is, what do I raise 10 to the power of to get 100? And the answer is 2. So the relationship is that this then becomes 10 squared is 100. Okay, these two things are saying the same thing. So here, that must mean that it's 3 squared is equal to x squared over x plus 4. I've undone the log. If you're not happy with that, just like no understanding the relationship, then you can raise both sides to the power 3. And then use the fact that these are inverse operations. So this just becomes x squared over x plus 4 is equal to 3 squared, which I wrote over here. Okay, so two different ways to get the same answer. So that's going to be 9. And then I'm going to times through by x plus 4 to solve this equation. And it's going to become a quadratic, isn't it? 9x plus 36 is equal to x squared. Solve a quadratic, get it all on one side. So x squared minus 9x minus 36 is equal to 0. And now we seek to put it into factorize it. So times to give minus 36, add to give minus 9. It's going to be 12 and 3. So minus 12 and x plus 3. That will work. Therefore, x is equal to 12 or minus 3. Now, we just need to be a little bit careful because we need to, like, sometimes when you combine logs, actually, you introduce extra solutions. Let me explain. Actually, minus 3 is an issue because whilst it was okay over here, minus 3 squared is 9, and 9 divided by 1 is just 9, and log to base 3 of 9 is 2. Actually, my original equation was this. 2 log to base 3 of x is not, this is not technically true. It's only true when x is, well, it's not actually, it depends what n is and everything. But basically, when you apply the log rules, you have to be a bit careful and you can introduce extra solutions. Sorry, I picked the wrong bit out here. So the best thing to do is just check whatever happens whenever you're solving a log equations. Okay, just get into good habits. Whenever you're solving really complicated equations and you're doing things like squaring or applying log rules, just check your answer at the end. And So actually what we needed right from the start here was that x had to be greater than 0. Okay, just by looking at this, we lost that when we combined it together, but it was a condition right at the start. If I was just solving this right from the start, then x equals -3 would be okay. But I'm not solving that one right from the start. I'm solving this right from the start. So reject x equals -3. X equals 12 is the one solution.